Hey everybody, we're going to talk about Chapter 2.6, the degrees of data abstraction. This is our last section here in Chapter 2. And this is kind of where we're going to put together the process that we've done with data modeling, how we're looking at all these different views, how we kind of put them together in this abstract fashion. Now, the initial views that we kind of work with, we take what's called an external model. Right? This is an external view of one particular user's view of the data. Right? So we said, hey, maybe this is the clerk's view of the data. What does the clerk need to see to interact with in the business? Okay, so maybe they need that list of widgets, maybe they need the list of customers, maybe they also need the suppliers list here, and any sort of information they're going to need here, right? Our suppliers, one supplier will make many widgets, right? And then our customers here will buy many widgets, and the same widget can be bought by many customers. So right, this is that many-to-many relationship here, and that's just one view of the data. So we start with these external views, and we need to start piecing them all together to get this conceptual model of, well, how does it all fit? Right? I'm going to take all of my different views here to make a single conceptual view, so I can put everything together. So I might also have my salespeople involved here. Right? The clerks are just dealing with some of the paperwork here. They're checking people out. We might have our sales staff. We might have our HR view of the data. Right? It's going to have the list of our staff over here. So how does our staff relate to this? Right? We have the salesperson working with a customer, but a customer works with one salesperson. So that conceptual view needs to integrate all of those different individual end user views together into a single database. And again, we're only looking at, okay, this is the noun, right? This is my entity, and this is the relationship. It's a one-to-many, it's a many-to-many, it's a one-to-one, whatever that needs to be here. Now, that's the conceptual view. That, sure, this is something we can talk about, we can draw nice pictures, but we don't really have a lot of fine detail yet. That's our conceptual model. Now, we're going to take our conceptual model, and we're going to get less abstract, right? We're going to get more specific and look at the internal model then on how we're actually going to store this in the database. So internal to the database is what we're going to look at. And this one means we need to break down every table, and we need to list out every attribute. Right? And what makes up those attributes? Are they integers? Are they characters? Are they dates? Right? Are they times? Whatever that happens to be, we need to get very specific around the actual data that we're going to be storing for each of these entities and that relationship here for our internal model. That's really how we're going to implement this at the database level. So this is going to be our good map of this here. So we're going to end up with our internal schema that's going to define, hey, these are my tables, these are all the fields and all the relationships among them as well. So we go from that conceptual external view to the internal database view. And then you can get even more specific from there as well to a specific physical model if you need to. And the idea with the physical model is, the actual location, the path, the format of the data, and it's very hardware and software specific. That's our physical design. Now, thankfully, most good relational database management systems take care of that hard work for us. They know how to nicely store the data that we ask it to. They're really good at that sort of thing. But there's some additional configuration you can do if you take a database administration class around file locations and paths and formatting and a couple other things that get a little bit specific there. But we kind of go through this view, right? We go from less specific to more specific, right? So we go from a very abstract view to a very specific view. So we have less abstraction at that physical model than we do at the internal model, than we do at the conceptual model, than we do the external model. So any external view we can implement in any relational database management system. Any conceptual view where we've taken that global view is still, the hardware and software don't matter at that point. Our internal view then is actually going to get specific. This is the real database here that we're going to be implementing for this particular database management system, right? So whether or not our flavor is the Microsoft SQL Server, SQL, or it's Oracle, or it's the MySQL database system, right? Or some other ones. It could be an IBM, something or other. I think there's this DB2. It could be the MariaDB. We got a lot of different databases. The actual software we're going to get specific to now for our internal model. And then just looking at going through that process of doing the data modeling, where we've taken all the different views, we've taken all these different pieces of data, we have to relate them here. So an interesting piece here with our internal model versus the conceptual model. So with an internal model, right, we need to know every table and every field or attribute, right? With the conceptual model, right, it's really just, hey, I've got this relationship and this relationship. Here's the name of my table. So this was my widgets. This was my customers. And one customer will buy many widgets, and many widgets will be bought by many customers. Now, we can't actually implement a many-to-many relationship in a relational database. Because if you think about how we did those relationships, when we said, okay, one agent would serve multiple customers, right? The crow's foot here, sorry. So if this was our customer relation, our customer entity, and our agent one, we have one agent for many customers. And one of the fields then the customer would have was the agent ID. So we would know, okay, which is this particular agent we had here? Because we said, well, I can't put an agent, I can't have a list of customer ID, I can't have customer 1, 2, 3, 4, whatever customer numbers here. We can't do that. That's not going to work for us. So if we have this particular many-to-many relationship, we can't transfer that to an internal model. That's no good. So a common way of doing this is we're going to join these tables together with a joining table. We're going to add another table here that they can relate to. So, a very common example here, we have the list of students. Student, right, would be the name of our table here. And then we would also have a section of a course. Like this is a particular offering, right? And many students would enroll in a section, right? Or students can be in more than one section, right? You're going to take more than one class, and one section can have more than one student. So from a conceptual view, this is fine. Right? We understand this is the many-to-many relationship. But in the implementation view, or an internal view, we can't do that. So we need to add a joining table here. So we're going to add an enrollment table. And then we can have the student table relate to the enrollment table. So one student will have many enrollments, but every enrollment will only have a single student ID. Student ID. Right? And then from enrollment, a section, then our section table, sorry, I should put those in the little box there, can have many enrollments, but every enrollment is for a single section. So we're going to have our student ID and we're going to have the section ID. So that we're going to relate to one instance of student and one instance of section for each one. So if I have many students enrolled in many sections, right, I can look at just the individual student and I can get all of their sections out. So I can search by my student ID, or if I want to find all the students in a section, I can search by the section ID as we go there. So at the conceptual level, we're fine to have these many-to-many relationships. At the internal model, we need to resolve them and handle them in a way that a relational database management system can deal with these joining tables here.